Scientists are shocked after the James Webb Telescope detects a massive structure that is older than our universe, which defies time and space and appears to predate the birth of our cosmos. Join us as we dig into the inconceivable and examine the secrets that lie beyond our grasp. The innovative James Webb Space Telescope has stunned scientists and cosmologists all across the world by identifying a massive structure that predates the very beginning of our cosmos. Surprisingly, this enigmatic entity appears to defy conventional cosmic chronology laws, testing our knowledge of the universe and raising significant issues about the nature of existence itself. The JWST's remarkable finding has sparked a frenzy among astronomers, enticing us to go on a mind-bending journey that transcends the bounds of space and time. However, the James Webb Telescope detects a massive structure that is even older than our universe. According to scientists, NASA's James Webb Space Telescope continues to detect galaxies that are too large to exist. 6 of these star clusters are significantly too big to be between 500 and 700 million years old, as their data shows. This suggests that, assuming the data was accurately examined, there is still something basic to learn about how galaxies evolved after the Big Bang. If the masses are correct, then we are in unknown ground, said Dr. Mike Boylan-Kolchin of the University of Texas at Austin. Our understanding of the universe has been irrevocably altered as the scientific world grapples with the startling revelation made by the James Webb Space Telescope. According to scientists, the cosmos expanded far faster following the Big Bang than is commonly supposed. The $10 billion JWST, which returned its first official photographs in July of last year, is designed to detect light from the most distant stars and galaxies. The greater the distance between two objects, the further back in time we are seeing. This is due to the amount of time it takes for light to travel from the item to us. It will be able to view almost all the way back to the beginning of the universe, around 13.7 billion years ago, thanks to James Webb's larger mirror. With its ability to survey the universe in longer wavelength infrared light, James Webb will be able to see some of our universe's most distant galaxies with greater ease than Hubble's visible ultraviolet light perspective. This is because light from distant objects is stretched out by the expansion of our universe, causing it to move out of the visible range and into the infrared. Because it takes longer for light to reach its 21-foot-long mirror, the further away an object is, the further back in time it is seeing. It is the largest and most powerful orbital space telescope in the world, and it can look back 100 to 200 million years after the Big Bang. Swinburne University of Technology in Australia conducted an analysis of data acquired on 6 galaxies in February. The first one they looked at was thought to be 13.8 billion years old, but the light JWST detected had taken 13 billion years to reach there. This meant that what they were seeing was a snapshot of the universe when it was only 700 million years old, barely 5% of its present age. This image, however, revealed that it was made up of 100 billion stars, the same number as the current Milky Way, which had 13 billion more years to grow. It was a similar situation for the other 5 galaxies, which had far more stars than would be expected for a cluster of their age. Dr. Boylan-Kolchin stress-tested these findings in a follow-up study published this week in Nature Astronomy. This is a framework for comprehending the function of dark energy and cold dark matter in shaping the evolution of the cosmos. The astronomy professor discovered that galaxies of this size and age are theoretically possible with this approach, but they are at an absolute upper limit. Scientists examined the data acquired on 6 galaxies in February. The first one they looked at was thought to be 13.8 billion years old, but the light JWST detected had taken 13 billion years to reach there. This meant that what we were seeing was a snapshot of the universe when it was only 700 million years old, hardly 5% of its present age. This image, however, revealed that it was made up of 100 billion stars, the same number as the current Milky Way, which had 13 billion more years to grow. When gas clouds collapse under their own gravity, they become increasingly dense and hot, eventually producing stars. However, part of this gas may be lost as a result of being expelled during the star formation process or being stripped away by an external force, such as a nearby supernova. We normally observe a maximum of 10% of gas transformed into stars, Dr. Boylan-Kolchin explained. Well, for these 6 galaxies to have grown as large as they have in their short existence, they must have converted nearly all of their accessible gas into stars. While 100% conversion of gas into stars is technically right on the border of what is theoretically achievable, it's really the case that this would require something completely different from what we expect, Dr. Boylan-Kolchin noted. This suggests that the CDM model on which cosmologists have depended since the late 1990s may not be entirely true. Dr. Boylan-Kolchin explained, "We'll need something pretty fresh about galaxy formation or a change in cosmology. One of the most extreme theories is that the universe expanded faster than predicted right after the Big Bang, necessitating the creation of new forces and particles. As a result, it is possible that the model will need to be modified to account for these new, faster galaxy formation processes. It is also possible that there was more matter accessible at the beginning of the universe for the development of stars and galaxies, which the model should account for. However, before scientists adjust their fundamental approach to cosmology, the JWST results must be confirmed as correct. It's possible that supermassive black holes heated up the gas surrounding galaxies, making them appear larger than they are. The light detected by the JWST may not have originated as far back as 13 billion years, implying that it may depict galaxies at more advanced ages. As light travels across expanding space, its wavelength is stretched and frequency lowered through what is known as redshift. The magnitude of the redshift helps scientists to compute when a star's light was emitted, although it can be influenced by dust and provide an incorrect age. It is hoped that additional research will establish whether or not this is the case. According to Dr. Boylan-Kolchin, if JWST data analysis continues to uncover the presence of stunningly enormous galaxies at very early cosmic epochs, further fascinating surprises await in the domains of galaxy formation and cosmology. The James Webb Telescope has been regarded as a time machine, capable of unlocking the mysteries of our universe. The telescope will be used to peer back into the early cosmos, more than 13.5 billion years ago, to witness the origins of stars, exoplanets, and even our solar system's moons and planets. The James Webb Telescope and most of its instruments operate at around 40 Kelvin, or around -387 Fahrenheit, or -233 Celsius. It is the largest and most powerful orbital space telescope in the world, capable of seeing back 100 to 200 million years after the Big Bang. The infrared observatory in orbit is expected to be 100 times more powerful than its predecessor, the Hubble Space Telescope. NASA prefers to conceive of James Webb as a successor to Hubble rather than a replacement, because the two will continue to work together for some time. The Hubble Space Telescope was launched on April 24, 1990, by the Space Shuttle Discovery from Florida's Kennedy Space Center. It circles the Earth at a speed of roughly 17,000 miles per hour in low Earth orbit at a height of about 340 miles. Hubble and Webb telescopes function as time machines. When the observatories stare into the depths, they are drenched in starlight that left its source eons ago and has been traveling across the cosmos towards us ever since. In other words, astronomers must seek out the most distant galaxies to understand the cosmic beginning. The picture of the early cosmos is developing more quickly than ever before. The discovery of these galaxies brings the entire picture of the early cosmos into doubt. This could not have been foreseen. Scientists are waiting for evidence, and only time will tell. The James Webb Space Telescope has discovered a structure that calls our current understanding of the cosmos into question. This incredible discovery pushes the boundaries of knowledge and inspires us to continue exploring the mysteries that lie beyond. Subscribe to our channel and join us on our space adventure. The discovery of a structure older than the universe itself tests our understanding and calls into question the fundamental laws that govern our existence. The consequences are enormous, as this ancient mystery challenges us to reconsider our concept of the beginnings of the cosmos. These discoveries serve as a sobering reminder that the universe we live in is far more amazing and strange than we could have anticipated. The universe is waiting to be explored, and we want you to be a part of this thrilling journey. Don't forget to watch the end screen video if you want to learn more about the Webb telescope's discoveries. We'll be back soon with a new video.